One thing that is also going to come into play with column design specifically is called the radius of gyration. And we represent that with a lowercase k in this course. And the equation for radius of gyration, k, is equal to the square root of I divided by a, where I is equal to the moment of inertia, and a is equal to the area. All right, so k is going to end up being a length. What k represents is if we have a concentrated line, we can draw a length k to that line and create the same moment of inertia. This is similar in thought to a force resultant and a distance for a distributed load. So that's k there. So let's do an example where we get to use k. X in feet, Y in feet, and I believe we've seen this area before. Maybe with my mad drawing skills. Y squared X is equal to 16. Where it crosses here at 4, crosses here at 2, and I wish to find moment of inertia about the x-axis, moment of inertia about the y-axis, the polar moment of inertia, radius of gyration for the x, radius of gyration for the y, and the polar radius of gyration. So look at all the fun things that we're going to find. Okay, this time my area is continuous against the y-axis. So I'm going to put y as the outer integral. Integral y, integral x, y squared dx dy, which is going to give me the integral from 2 feet to 4 feet of y squared x dy. So that means I need x in terms of y. So coming up here, x is equal to 16 divided by y squared. Or if you prefer, 16 times y to the negative 2, whichever. So this is equal to the integral of 2 feet to 4 feet of y squared times 16 y to the negative 2 dy. And that value ends up being 32 feet to the 4th power. By y, again, I'm going to put the integral y on the outside, x squared dx dy. So that's going to give me 2 feet to 4 feet of x cubed divided by 3 dy, which is going to be the integral of 2 feet to 4 feet of 1/3 16y minus 2 cubed dy. And that gives me 8.27 feet to the 4th for my inertia. By the way, ladies and gentlemen, inertia is always positive. So if you end up with a negative inertia, you've done something wrong and you need to go back and check your work. My polar moment of inertia, I'm going to add these two together, 32 feet to the 4th plus 8.27 feet to the 4th is equal to 40.3 feet to the 4th. And I am not underlining anything, so here's my answers. Yay! All right, so now that I have that, I need to find radius of gyration, and for that I need my area. Area is equal to the integral from 2 feet to 4 feet of 16y minus 2 dy, which is equal to 4 feet squared. Therefore, kx is equal to 4 feet squared divided into 32 feet to the 4th, square root of that. So you see we get feet squared and then we find the square root of feet squared. So that gives us 2.82 feet. Ky is equal to 8.27 feet to the 4th divided by 4 feet squared. Square root of that is equal to 1.44 feet. And then my polar radius of gyration, 40.3 feet to the 4th divided by 4 feet squared. And that is equal to 3.17